Hey guys, welcome back once again. Today we're learning about Mathematical Standard 8 EEB 5, which means we're learning about linear equations today. So our learning target is going to be to construct equations that represent proportional relationships as well as understand the idea of slope. Success criteria, first thing, I can read a graph and determine points. If you are given a graph, I should be able to see what the values are in that graph. What's the x, what's the y, and what do those points mean in the context of the problem? Secondly, I can interpret real-life situations into mathematical operations and symbols. Remember a while back before break, we made a whole chart that told us what means add, what means subtract, what means multiply, what means divide, and what means equal. You're going to keep those in the front of your mind because if you're given a context, you're going to need to translate that into an equation. Lastly, I can connect the multiplier of an equation as representing slope. So we're going to talk a little bit about this vocabulary word slope, and it is going to be a synonym for multiplying by the x. All right, so let's start on our first example. It says the graph shows the distance d a car travels in time t at a constant speed r. That's a lot of variables. I'm going to highlight some of that just to show that it's some important information. I know that distance is the variable d, time is the variable t, and speed is the variable r. Now you may be thinking, well, why did they call speed r? That's probably because a lot of times speed is called rate. So I'm going to write that down just as a little reminder here. Okay, rate is like saying speed. So that's why they're labeling R as speed, because they mean the same thing. Okay, so we're going to answer a few questions here. There's actually 4 different questions that it's asking us about this graph. First, what is the constant speed of the car? Constant meaning unchanging. Well, let's take a look at some of the values on this graph. We have 0, 0. Okay, and if you notice, I'm only really pointing out values on the line that cross over intersections of the grid lines. Okay, so I'm just highlighting them by putting red dots so that I can easily read where they are. Now there are points in between these red dots on the line, but I'm only highlighting these red points because those are integer values. So if I create a table and just read off some of these values, I create a table just because it's easier for me to pick out patterns when I see the numbers side by side. So I'm just going to read some of them off here. First, there's 0, 0. The second point I see in red is 130, 260, 390. And that should be fine. I don't need to label all of my points in the table. I think I can figure out the pattern just by looking at this. So I'm seeing for every hour that goes by, okay, so we have 1 hour passing, that means we gain 30 miles, okay? X was time and Y was distance. So for every hour that passes, 30 miles get added, and it actually continues that way throughout the entire table. All I'm doing is adding 1 on the x's and adding 30 on the y's. That should be indicating to us that constant speed they're talking about. Whenever we talk about speed, we talk about mph, or miles per hour, right? So how many miles per hour are we traveling? Well, in 1 hour, we've traveled 30 miles, and it's the same throughout all of the different points. So our constant speed is 30 miles per hour. Whenever you want to write the word per, using that division symbol or that slash is the same thing as the word per. So the answer for part A would be 30 miles per hour. For part B, it says, how far will the car travel in 2 hours? Well, that's just as easy as reading the point from the graph or even from the table. So I'm just going to look up 2 hours on the graph. There it is. Look up to where the line is at that value, which is at this red point right here, and then I want to look at the distance that it's lined up with, which is 60. So in 2 hours, we're going to travel 60 miles, and that's actually present in our table as well. So let's move on to part C. It says, how long will it take the car to travel 120 miles? So let's do the same thing. Let's go over to the miles, which is the vertical axis. Here's 120 miles. Let's locate the point that's on the graph, which is this point right here. And now we need to figure out what it lines up with in the time, which is 4. So it's going to take us 4 hours to travel 120 miles. Last question here says, write an equation in D equals RT form to model the situation. This is actually a really important formula, D equals RT. You're going to be using this formula in science all the time. So really what this formula is saying is distance is equal to rate or speed times the time. Well, the constant speed here is 30 miles an hour. The distance is always changing and the time is always changing. So we don't want to plug any numbers in for the variables that are constantly changing. So we want to keep the D, the variable D, and then we want to keep the t, the variable t, but we want to plug in the speed. Well, we figured out the speed is 30 miles an hour. So I'm going to plug in 30 where r sat in the equation. So instead of the letter r, I just wrote the number 30 because that's what the rate is. The speed is 30 miles an hour. So my equation is distance is equal to 30 times the time, or 30 miles per hour times time. So now let's have you go ahead and try your U-try.
What we do here is go back.
All right, so let's go over the key concept of this lesson today. It says, recall the graph of a proportional relationship is a line that passes through the origin. An equation that models a proportional relationship can be written in the form y equals mx. The equation y equals mx shows y is always a constant multiple of x. Now, what that's trying to tell you guys is if we think back to the example that we just did, the D equals RT example, so this one, D equals RT, distance equals rate times time, that should remind you of what it's saying here with y equals mx. Distance equals rate, oops, that's not an R, rate times time should look just like y equals mx, where D is the same thing as y, T is the same thing as x, and then R is the same thing as M. R is what multiplies T, M is what multiplies X. We talked in the last example about how D and T were the variables that were changing throughout our table, and that's going to be the same for Y and X. Most of our tables that we've created have to do with Y and X. They don't have M. M is the thing that doesn't change. It's what always multiplies each one of the X's. So I want you guys to think of y equals mx as y being the output, or the dependent variable, x is the input, which is the independent variable, and then m stands for the multiplier. So whatever you figure out is multiplying x, that should be going into the m position. We call this a linear equation. If we think about linear equation, the root word linear, the root word of linear is line. So if your graph forms a straight line, then it is proportional, which y equals mx represents a proportional relationship. So if you see a straight line and you see it going through the origin, it is proportional. Now, if you don't see a graph and they just give you an equation, if it's in the form y equals mx, then it is proportional. So let's take a look at our second example. It says a restaurant is running a lunch special. Write an equation that models the lunch price, y, based on the original price, x. Now, this is a little different here because if we look at the sign on this person, you know, this person's trying to advertise here for their lunch special. If we look on the sign, it says all prices 1/3 off. Well, let's think about what 1/3 off means, okay? Because whenever you see a number, I don't want you to just throw it into the equation anywhere you think, because the equation that we want to write is y equals mx. We want to plug something in for m. We want to leave the y and the x alone. We want to figure out what number can we plug in for m. What would we multiply x by to get to y? Well, x, let's call x the original cost. Let's call y the special price. Okay, so what can we multiply the original cost by to get to the new cost, y? Well, let's think about this in terms of pizza, because that's, I think, is the easiest way to deal with fractions and the word off, because different words mean different things. The word off means you want to take 1/3 away from the original price. So let's think about a pizza. If I were to split this pizza into thirds and I were to take one of those thirds away, I would have 2/3 left over. So I have 2/3 of a pizza. So what I would do is I would do 2/3. The word of means multiply, and I would multiply it by one of the pizzas, which means I would have 2/3 of a pizza left over. So I want you guys to keep that in mind, that if I want to take away 1/3, I'm really just multiplying something by 2/3. So let's put this in perspective here. Let's say I have the number 9. If I want to take away 1/3 of 9, 1/3 of 9 means multiply it by 1/3. So that's 3. If I want to take that away from 9, 9 minus 3 is 6. So 1/3 off of 9 is 6. Well, that's just like saying 9 times 2/3. If you were to type 9 times 2/3 in your calculator, you're going to get 6. So whether you multiply it by 1/3 and then take it away from the original price, or you just multiply by 2/3, it's going to do the exact same thing. So what I want to do with this is now just create our equation. Our equation needs to be in the form y equals mx. So my multiplier here should be 2/3. So my ultimate answer here, my equation should be y equals 2/3 x. So now that we've done that, go ahead and take a look at your U-Try. All right, we've got one more example that we need to go through and one more U-Try. The number of words y you can type in x minutes can be represented by the equation y equals 55x. The number of words your friend can type in x minutes is modeled by the graph. Which of you can type faster? So right now this question is asking us to compare two things. The first thing is you. So the number of words you can type in x minutes can be represented by the equation y equals 55x. So I'm going to make two different columns here, one representing me, one representing my friend. They already gave me the equation for me, y equals 55x. Now, my multiplier is 55. That's my rate. If I think about what the situation means when we talk about words being typed, this 55 means that I can type 55 words per minute. That's what that multiplier indicates. It's always going to be a something per something. That's what that multiplier is for. Think back to our very first example when we had D equals RT. We plugged in rate, and rate was always miles per hour or something had to do with speed. Well, the same thing goes for this, the speed to which I type. So for me, that 55 represents 55 words per minute, which makes sense because it said Y was words and X was minutes. Well, I need to figure out how many words per minute my friend types just by looking at her graph. So the first thing I want you guys to think when you're looking at a graph is highlight a few points that you can definitely read. So nothing really in this area I'm going to be able to read until I hit this intersection. I can definitely read that point right there. It's 3,150. I can read this point, which is 6,300. I can read this point, 9,450, and so on. Okay, so I basically just created a quick table. I could put those numbers into a table if I wanted to, but I'm not going to, just to save a little space. Okay, but I can take this value, 3,150, and interpret it in the context. That 3 represents minutes. The 150 represents the words. So really this is saying that I can type 150 words, or my friend I should say, 150 words in 3 minutes. Well, what does that mean about 1 minute? Because right now my speed is 55 words per minute, which just means in 1 minute I can type 55 words. Well, how do I figure out how many words my friend types in just 1 minute? Well, I just have to figure out, I have to divide by that 3 minutes. Take the 150 and divide it by 3 to get how many words in 1 minute. Well, 150 divided by 3 is going to be 50. So the equation for my friend should be y equals 50x. And now I can actually compare their multiplier to mine. So hers is that she can type 50 words per minute. So if I'm going to answer this question, which of you can type faster, I would definitely say I can type faster because 55 is larger than 50. Go ahead and try this same type of process on the U-Try-3. Again, they're going to give you 2 different forms. One's going to be an equation, one's going to be a graph. You need to pull out the multipliers for each and make sure it's per 1 of each of the units.